Hi everybody, today on 1 Minute Math you're getting the full-length explanation of range. So this would be the partner video or partner topic to domains. And this would be in Algebra 2 mostly, maybe in a pre-calc class, possibly in a very advanced Algebra 1 class. We're talking about algebraic functions, things like polynomials, power functions, rational functions, absolute values, not trigonometry, exponents, or logs, not transcendental functions, only algebraic functions. But the question here when it comes to range, so I give you a function, right, and let's put a bunch of stuff on here. Let's just put an x of every power, and how about plus 8 at the end, because 8's my favorite number. The question is, what are the possible values that I could get as answers when I plug in any x I want? Can you categorize the answers that I'm going to get? And for a lot of algebraic functions, the answer for range is all real numbers, as it was for domains, right? In domain land, range is slightly more tricky than domain. In domain land, the answer was almost always all real numbers, except for 1 over x and square root x. Here in range, the range is going to be all real numbers, except for 1 over x and square root x, and absolute values and any even power function, like x to the 4th, x to the 8th, x to the 10th. Yeah, and range, while I'm here, I'm just going to point out nobody cares about range outside of the context of Algebra 2 or whatever. You're going to get through this chapter, you'll be able to say what the domain and range, domains are super, super important, but you'll be able to find the domain and range of a function in this chapter, you'll do it on the test, and if you forget it forever after this, that's totally fine. If you end up going real far in math, there are much better words we use for this concept that we call range in high school. We're really talking about the image of a domain in a codomain. So we don't really care about range so much outside of this context. That's just to give you a little bit of comfort. If you find this like confusing and you're not sure you're going to remember it forever, it doesn't matter. But it's still important to note, like, you do have to, it's not a great word for it, I don't love calling this concept range, but everybody in high school does, so we just run with it. And it's good to, like, familiarize yourself with understanding what the inputs and outputs of functions are. So let's take a look at those 4 functions I talked about. 1 over x, root x, x squared, or using x squared as a representative of any power function with an even power, and then absolute value. And let's start with 1 over x, because he's kind of the oddball there. The rest of them have very, very similar answers. So 1 over x, when I ask the question, what answer can I or can't I get? If you ask me, can I find an x that will make 1 over x equal to 2? Yep. 1 over 1/2 equals 2. Can I find an x that will make 1 over x equal to 2/3? Yep. 3/2. Can I get negative numbers? Sure. Can I get rational and irrational numbers? Sure. I can get almost every number as an output, except, is there a number I can divide by and get 0? And hopefully you realize that there is not, and therefore y does not equal 0. My range for 1 over x as this function is every real number except 0. I can use my little trick. In domain land, sometime we talk about this trick of like looking for the shadow on the x-axis. So here in range land, I'm going to do a similar trick. Here's my function 1 over x. And I'm going to shine a light now. Imagine that I'm shining a flashlight onto my function. I'll shine it from the left, I'll shine it from the right. And I want to see what kind of shadow is produced on the y-axis. So in domain land, it was like, what kind of shadow do I get on the x-axis? But here, if I've shown this flashlight, I'm going to actually shine it from this direction, and I imagine what gets covered up on the y-axis. I can see I'm going to get shadow all the way here, I'm going to get shadow all the way here, but I will not get a shadow right on the x-axis, and therefore y cannot equal 0 as an output. Now, if I take that same concept, I'm just going to add some stuff to my function here. Okay, so now I'm going to examine what happens if I have like 1 over x minus 7. It doesn't even matter what's underneath there, and I have a plus 5 here. You might be familiar with what's going to happen here. That plus 5 is going to act as a vertical shift on my function. This one also has a horizontal shift because of that minus 7. But here's my 1 over x kind of graph now, and you can see that when I shine my light, what g of x can't equal, what y can't equal, is it has now been moved up to 5. Alright? So in this 1 over, in rational land, what you care about is what's on the outside. If I have 1 over whatever plus some number k, y can't equal k, and that is my range. All right, now let's tackle some of these guys. Let's start with square root. We'll start with the radical one. I've got lots of space here. Okay. F of x equals square root x. We know that I can't put negative numbers in there, but it's probably, hopefully, pretty obvious that I also can't get negative numbers out. No matter what number I put into the square root, I'm always going to get a positive answer out, or 0. The square root of 0 is 0, so 0 is okay to include in my domain and my range. If we approach this from the graphical standpoint, here's my function. And I'm going to shine my flashlight. We can see that what's going to be shadowed on the y-axis now is from 0 all the way on up, but nothing down here. I get no shadow in there. So y is greater than or equal to 0 really is my my range here. And if I add something on the end, and again, it doesn't matter what I have in there, if I have square root of 2x minus 4, okay, that doesn't really matter at all. That would still have a range of y is greater than or equal to 0. But now if I add something on the end, that's when I have a vertical shift of my graph. If I just take this much, that's going to move my graph to the right, and I would still get the same kind of shadow. But when I add that plus 3, now the shadow has moved up, and I only get the y is greater than or equal to 3. So generally speaking, if I've got the square root, I can have any number out here. Let's say a. Square root of x minus h plus k, y greater than or equal to k. Sweet. Now, let's check out the last two, y equals x squared, or any even power, but x squared is a good example to have. Okay. That one goes like this. A nice little parabola, touches 0 down there. And then y equals absolute value of x, which is a graph that looks like a V and has a sharp corner. Corner is the name you want to use for that kind of feature on a graph, by the way. It's not a point. There are lots of points on a graph. But a sharp corner at 0. Do you see the similarities between these two? Like, imagine taking my flashlight here, and regardless of which one I shine my flashlight at, I'm going to get... Oops. There we go. I'm going to get a shadow on the y-axis for both of these. That is all positive values of y and 0. Just like square root land. So square root, square, or even power of x, and absolute value all follow very, very similar patterns when it comes to range. And the same thing goes if I take this x squared graph and I add some stuff to it. I add, how about minus 1, minus 5. Okay, that's going to move my graph to the right 1 and down 5. And we'll make it taller. That 3 will make it taller. This thing on the end is still the only one I care about. Same thing would happen in absolute value land, just moving that vertex around. Y is greater than or equal to whatever that last number is. Now the last thing we've got to consider here, though, is that with all three of these, if I have, I'll call it g instead of f, negative root x, or negative x squared, or negative absolute value of x, that moves my graphs upside down entirely. Here's negative square root x. Here is negative x squared. And negative absolute value. So now instead of having y greater than or equal to 0, I'm going to say y is less than or equal to 0. Same rules still apply, though. If I had a number out on the end there, would be y is less than or equal to whatever that number is. All that changes is the direction of the greater than or the less than sign. I'm not going to make 3, negative 3, or anything like that, okay? Just take that same number and less than if we have a negative symbol out front. All right, I hope that you found this helpful. Thank you for playing along, and stay tuned for the next video.